Let's take a look at an example of stage one numerically. Suppose you have a volatility of interest rate being 0.01 and A is 0.1 and your delta T, just for simplicity, is 1. Now for that, you can calculate the steps for interest rate change. So in this case, according to the formula, you will have a delta R star is equal to 0.01 square root of 3. That will give you 0.0173. Okay, so that's like 1%. 1.7%. And your J max and J mean will be 2 and minus 2 respectively. So if you calculate that according to the formula here, and okay, so if you have basically 2 steps up, then you should switch to only going down branches. And if you go 2 steps down, you then need to switch to going up branches. So here we'll have a tree like this. And you should start with 0. And basically here you start with branch type A here. So and here along this line here, the rates will always be 0. And here this part will be 0.0173, so 1.73 here. And then from here, you still have type A branching. And once you get to here, you can only go down. So, you go unchanged, or you go 1 step down or 2 step down. If you reach node I, you then switch to only going up. So either you go 1 step up or 2 steps up. So since you know what R and delta R's are, so your initial R is star is always 0, then you can put it together nodes like this, and we calculated based on this what the changes are. So we can put the numbers here. So the probability is then calculated based on the formulas we have before. So if it's a type A type of branching, our probability is given by this set of formula. If it's type B, we're gonna go by this set of formula, and type C go by this set of formula. Okay, so here, if we go to E, the probability of this will be by type C, and here will be type B. And from A, B, C, D, E, G, H, they're all type A kind of branching formulas. So if you take the formula, A will U will be 16.67%, M unchanged will be 66.66%, and D is actually symmetrical. So in this case, will be 16.67% as well. And you notice that under for the nodes A, C, and G, they all have the same probability here and here. And for B and E, they will have So for B and E, they have the same probabilities of branching out. D and H will have the same probability of branching out. So there are actually structure here like you can take to fill out this table immediately to help you fill them out faster. Now we're moving to phase 2.